So at this stage in the course, we just learned about the energy equation. Earlier in the semester, we learned about the conservation of mass equation. And so I'd like to utilize both of those applications in an example, really highlighting more the energy than anything else. In this case, we have, say, a residential house. We have a spigot at point 1. And say we have a garden hose that's about an inch, right? 2.5 millimeter diameter. Maybe we have 30 feet of it, which is 10 meters. And at point 1, we know that the pressure is about 120 kilopascals. Just to put that in a sense of English units, 120 kilopascals would be roughly 17 and a half psi. And at point 1, we measure the velocity to be 7 meters per second. And what we'd like to know is at point 2, which again is 10 meters away from point 1, what would be the pressure if we registered that the velocity is 4 meters per second? So we have a velocity that's changing from 7 to 4. At point 2, we also know that the elevation at this point is 2 meters. Okay. So we're going to start just by just writing the general energy equation, Bernoulli equation from point 1 to 2. Okay, and I start by always writing out all the terms of the equation. Let's see, so I've got P2, V2 squared, 2G. Okay. There we go. Okay, so in this version of the equation, again, I have the energy at point 1 essentially is equal to the energy at point 2 plus any losses. Okay. Now, a couple things before we get started. First of all, I'm going to assume there's no head loss. Head loss is basically energy loss. We just learned about the energy equation. In the next couple lessons, we'll be dealing with head loss. At this stage in the game, we don't know anything about that, so I'm just going to assume it's 0. So this term right here, we're just going to let it go to 0. Okay. A couple other things. For water, recall that specific weight of water. Again, this is a rule of thumb value. It's about 9.1 kilonewtons per meter cubed. Okay, now I express that as kilonewtons because when I looked over here, I was using kilopascal, so I'm thinking that everything should be expressed in terms of kilo. Okay, and we just have to be really careful with the units. Okay, so let's go ahead and start substituting some of these terms in. I've got P1 here, which is 120. A kilopascal is a kilonewton per meter squared. Okay, that's divided by gamma, which is the 9.81. And that's kilonewtons per meter cubed. I've got the second term here with velocity. The velocity at point 1 is the 7 meters per second. We're going to square that. We're dividing by 2 times g. Gravity in SI units is 9.81 meters per second squared. And then we have z1. So we can go about this 2 different ways, depending on where we want to make the datum. If we want to make the low point our datum, which is common, z1 would be equal to 0 and z2 would equal 2 meters. However, we could always make point 2 the datum, and this would be 0 and this would be minus 2. So it's kind of 6 one way, half a dozen the other. I generally use the low point as the datum. So in this case, z1 is equal to 0. Okay. And then I start substituting in the terms for point 2. Now, I don't know the pressure. That's what we're going to be solving for. I know the velocity here was given to me as 4 meters per second. So we'll square that, divided again by 2 times 9.81 meters per second squared. And then I'm going to continue this right here. And then our Z2 is 2 meters. Okay? So after I go through, I'm just plugging and chugging. After I substitute all these terms in and I calculate it, on the left-hand side, I get 14.73 meters. And then on the right-hand side, I get, of course, the P2 over gamma plus the 2.82 meters, which is what all this represents. Okay, when I simplify that a little more, I get 11.91 meters on the left-hand side is equal to P2 over gamma. And then what I'll do is I'll just solve for P2 by multiplying by gamma. So I'll have 11.91 meters times gamma, which was 9.81 meters. I'm sorry, kilonewtons, and again, I was getting ahead of myself, meters cubed. and all that's going to be equal to P2. So you have meters, and then the denominator have meters cubed, so that's going to give us kilonewtons per meter squared. Okay. And a kilonewton per meter squared is also known as a kilopascal. So we have 116.84 kilopascals as our final pressure at that point. Okay, so again, just to recap, what we did is we wrote the equation from two different points, okay? Again, you can choose whatever points you want, but we chose the points where we knew things. We knew at point 1 what the pressure and the velocity was. We knew at point 2 what the elevation was and what the velocity was. And from there, we pretty much we had to make an assumption regarding the head loss. But other than that, we just kind of marched forward, we substituted all the terms in, and we just solved for pressure directly. And that concludes this example of the Bernoulli equation.